Okay, we're going to look at a couple examples of what's called function evaluation. We're going to look at what's called single evaluation, which means one iteration of evaluation. Okay, and we're going to see here that we are asked to please evaluate the given function as indicated. The given functions here are g at x, f at x, and m of x. I'll leave those to your reading if you just take a second to look at them. And here we are asked to evaluate what is read f at 20 in problem number 1. Problem number 2 is g at -4, or g of -4, it could also be read. And in number 3, a little different, m at -3b. And we notice here that this input value has a variable in it, where the input values in these previous problems are just very simply integer numbers. So, what this means to do when we say f at 20, it just means to, quite simply, to take 20 and plug it in for x in f of x and simplify. So I will do that by doing equals 3 minus the absolute value of 12 minus, now plugging in the value of x, 20. Okay, I'll take a second to simplify that. 3 minus 12 minus 20 is -8, which is equal to 3 minus the absolute value of -8 is 8, which is equal to -5. So the way this can also be looked at is that -5 is the output when the input is 20 for the function f of x. Okay, let's continue on to another example. This is going to be g at -4, which quite simply means to take -4 and plug it in for x, in this case in 2 places, in g of x, and simplify. So let's take a look at doing that. I'll plug it into the numerator's x and get -4 minus 5 over -4 plus, excuse me, trying to color coordinate here, plus 4. And when we simplify the top, we get -9. When we simplify the bottom, we get 0, which you must, under all circumstances, when we see this 0 in the denominator, you must remember that this means it's undefined. This means, in fact, when we use 4 as an input, excuse me, -4 as an input in the g function, there is no output, because it leads us to an undefined number. Okay, number 3 now, a little mildly different example. Okay, it says to do m at -3b, which means to take -3b and plug it in for x in -4x squared. So, just quite simply, we're going to write -4 times -3b to the second power. Now, just being careful here with our order of operations here, you're not going to do -4 times -3 first. You're going to do -3b raised to the second power, because the exponent needs to come first. So, I'll just pull down my -4. I'll square my -3b. When I square the -3, I get 9. When I square the b, I get b squared. Simplifying that further, I will get -36b squared. Which means when I use the input of -3b in the function m of x, I get an output of -36b squared. Again, this is a process by which you are given an input and a function, and you plug in for x in that function, plugging the input in to generate an output. Okay? Mechanically, this process is one of just plugging in a given value for x, simplifying by using the order of operations as best you can. Okay? It's meant to be kept simple. The only tricky thing about it potentially is the notations and understanding what they are asking you to do. So feel free to watch again and try an example or two yourself.